So, today I'm going to be talking about Newton's first and second laws. I'm not going to be going into depth because you can be going in lots of depth, but I'll just go over the basics. Let me begin. Inertia, which Galileo Galilei came up in the 16th century, is the property of an object to resist change in motion. Every object, no, this is Newton's first law. Every object continues in a state of rest or of uniform speed in a straight line, unless acted on by a non-zero net force. For an example, if you have an object that's being acted by 10 newtons on the right side, 5 newtons on the left side, the net force will be 5 newtons, so it will be 5 newtons in this direction. It will not want to slow down if gravity is not acting on it and it's on a frictionless surface. When the net force is equal to 0, it's called mechanical equilibrium. And the definition of 1 newton is equal to 1 kilogram meter over second squared. So, in order to transition into my next topic, I must tell you this. As mass increases, acceleration decreases. This will make sense with Newton's second law. Newton's second law, in simple terms, basically states the acceleration of an object is equal to the F net over the mass of the object. And as Isaac Newton put it, very smart man, the acceleration of an object is directly proportional to the net force acting on that object, and is in the direction of the net force, and is inversely proportional to the mass of the object. Now, from this we get terminal velocity, which is when gravity and drag is balanced, so it continues in the same direction without acceleration, which is inertia. Gravity is actually not acting on the object, it's just inertia in the downward direction. It's just a coincidence, it happens to be going downward. So, when you are free falling, gravity is pulling you down, and drag is pulling you up. You fall, until drag equals the gravity, because the faster you fall, the more the drag gets. And you continue in the same motion downward, so there is no force acting on you. You continue the same motion as stated in the Newton's first law. When you pull your parachute, your drag slows you down because air catches in the parachute, and you fall, and gravity pulls you faster and faster until you reach another terminal velocity where drag equals gravity again. You still don't accelerate, and it's still inertia, but you happen to go slower. They both share the common factor of the fact that you do not accelerate, and there's no forces acting upon you, except for Newton's first law, which is every object continues in a state of rest or uniform speed in a straight line, aka downward, unless acted on by a non-zero net force. And there is no non-zero net force acting upon you, so you continue in straight motion. Thank you.